Each question is followed by two statements, and our task is to determine whether the given statements are sufficient to answer the question or not. So let us first understand the option. Option A states that only one statement is sufficient. Option B states that either statement alone is sufficient. Option C states that both statements together are sufficient. Option D states that even both statements together are not sufficient to answer the question. Now let us solve the question. The question goes like this. X receives 3 coins of different denominations 1, 2, 5, 10 and 20. If the total amount received by X is M, then does X receive a coin of denomination 5? So let us first understand the question. We have 5 coin denominations of 1, 2, 5, 10 and 20. X receives exactly 3 different coins and the total value is M. Now we have to determine whether one of these 3 coins is of rupees 5. Since we have 5 denominations and we have to choose 3 different coins, the total number of possible combinations is 5C3. This is equal to 10. Since there are only 10 combinations, let us list all of them. First, let us write the combinations in which rupees 5 is present. So, these combinations will be 5, 1, 2, 5, 1, 10, 5, 1, 20, 5, 2, 10, 5, 2, 20, 5, 10, 20. Now let's list all the combinations in which 5 is absent. So these combinations will be 1, 2, 10, 1, 2, 20, 1, 10, 20, 2, 10, 20. So we have listed all the 10 combinations. Now let us calculate the value of M for each combination. So M is the sum of all the coins. 5 plus 1 plus 2 gives us 8. This gives us 16. This gives us 26, 17, 27, 35, 13, 23, 31 and 32. Now that we have all the possible values of M, let us test the statements. M is not a prime number. So let's check the cases in which M is not a prime number. 8, 16, 26, 27, 35 and 32. Since 32 does not contain 5, statement 1 is not sufficient. Now let's check the statement 2. It says that the sum of digits of M is greater than 5. So sum of 8 is 8, 8 is greater than 5. 16 is 1 plus 6 is 7, 7 is greater than 5. 2 plus 6 is 8, 8 is greater than 5. 1 plus 7 is 8, 8 is greater than 5. 2 plus 7 is 9, 9 is greater than 5. 3 plus 5 is 8, 8 is greater than 5. In the second case, in which 5 is absent, 1 plus 3 is 4, 4 is lesser than 5. 23, 2 plus 3 is 5, 5 is not greater than 5. 3, 1, 3 plus 1 is 4, 4 is not greater than 5. 3 plus 2 is 5, 5 is not greater than 5. So we can see that in the cases in which the sum of digits of M is greater than 5, 5 denomination is present. Hence, statement 2 is sufficient. Therefore, statement 2 alone is sufficient and the correct answer is option A. The question goes like this. For two distinct real numbers x and y, which of them is bigger? So we are given two statements based on which we have to identify the correct answer option. So let us take this first statement. First statement states that x square is less than y, which is less than 1. So let us take two cases. Case 1, x is less than y. So let's take x equals to 0.5 and y equals to 0.6. So here the condition is satisfied since 0.25, which is x square, is less than 0.6, which is less than 1. So this condition is satisfied. Here x is less than y. Now let's take x greater than y. So let's take x greater than y. X will take as 0.9 and y will take as 0.85. So here x square will be 0.81, which is lesser than 0.85, which is less than 1. So here as well the condition is satisfied. So statement 1 is not sufficient to answer the question. Now let's take statement 2. So statement 2 states that y is less than root x, which is less than 1. So let's take two cases. First case, x is greater than y. So let's take x as 0.25 and y as 0.2. So root x will be 0.5. Here the condition is satisfied since 0.2 is less than 0.5, which is less than 1. So the condition is satisfied. Now let's take another case. In this, x is less than y. So let's take x as 0.25 and y as 0.4. Root x will be 0.5 and therefore 0.4, which is y, is less than 0.5, which is root x, and this is less than 1. So here also the condition is satisfied. So in both the cases the condition is satisfied. Therefore statement 2 is also not sufficient to determine which number is larger. Now let us combine both the statements together. So combining both statements 1 and 2, we get x square is less than y, which is less than root x, and this is less than 1. So let us take two cases. Case 1, x is less than y. So we are taking x as 0.25 and y as 0.4. So x square will become 0.0625. So this is less than 0.4 and this is less than root x, which is 0.5, and this is less than 1. So the condition is satisfied here. Hence, x less than y satisfies the condition. Now let us take condition 2 in which x is greater than y. So we will take x as 0.25 and y as 0.2. Now x square will become 0.0625. So 0.0625 is less than 0.2, which is less than root x. Root x is 0.5 and this is less than 1. So in both the cases, the condition is satisfied. So even after using both the statements together, we still cannot determine which number is larger. Therefore, the correct option is option D. Even both statements together are not sufficient to answer the question. I would like to remind you that the questions like this can be time consuming. So in the paper, it is usually better to prioritize other questions and revisit tough questions only if time permits. The question goes like this. If x and y are integers, then is x even? We are given two statements based on which we have to identify the correct answer option. Before we begin, here's an important concept. The square of an integer has always the same odd even nature as the integer itself. In other words, square of an even integer will always be even and square of an odd integer will always be odd. Now let us evaluate the statements one by one. Statement 1 says that x square y square is even. So a product is even if at least one of its factor is even. So this means that at least one of x or y must be even. But we still cannot determine whether x is even. Therefore, statement 1 is not sufficient to answer whether x is even or not. Now let us move to the next statement. Statement 2 states that 1 plus x square plus y square is odd. This means that x square plus y square is even. This can be only possible if both x and y have the same parity. This means that x and y should have the same odd or even nature. So if both are even or if both are odd, this condition will be satisfied. But again, we cannot determine whether x is even. Therefore, statement 2 is also not sufficient. Now let us combine both these statements together. So from statement 1 we got that at least one of x and y must be even. And from statement 2 we got that both x and y are of the same odd even nature. That is, both are odd or both are even. So the only possibility that satisfies both these conditions is that if x and y are both even. So x is definitely even if both these statements are true. Therefore, both statements together are sufficient to answer the question. Hence, the correct answer is option C. Now, let me briefly explain the question first. We are given that x is a collection that contains only odd numbers and y is a collection that contains only even numbers. And every element of a collection T belongs to either x or to y. Our task is to determine whether every element of T belongs to y. That is, whether all the elements of T are even. So, let us evaluate the statements given one by one. Now, let us take statement 1. Statement 1 says that the sum of any two numbers belonging to T is even. So we already know that all the elements of T are either from X or from Y. This means all the elements will be either odd or they will be all even. So this condition is always satisfied because even plus even will give us even number and odd plus odd will also give us even number. So we cannot determine from statement 1 whether all the elements of T are from Y or all of them are even. So this statement is not sufficient. Now let us look at statement 2. Statement 2 states that if both P and Q are picked from T, then P minus 1 into Q is even. So P and Q are elements of T. They are either the elements from X or they are both from Y. This means they are both either odd or they are both even. So P minus 1 into Q will be always even because if P and Q are odd, then P minus 1 will become even and Q will become odd. So even into odd will give us even. And suppose if P and Q are even, so P minus 1 will become odd and Q will be even. So odd into even will also be even. So this condition is always satisfied. If all the elements of T are even, then also this condition is satisfied. And if all the elements of T are odd, then also this condition is satisfied. So statement 2 is not sufficient to answer the question. Now let us combine both the statements 1 and 2 together. From statement 1, T is either entirely odd or entirely even. Statement 2 is also satisfied in both the cases. So both possibilities still remain. Therefore, even after combining the statements, we cannot conclude that every element of T is even or every number of T is from Y. Hence, the correct answer is option D. This question cannot be answered even after using both the statements. So the question goes like this. If x, y and z are integers, each greater than 1, then is x a prime number? So we are given two statements based on which we have to identify the correct answer option. So we are given that x, y and z are integers that are greater than 1 and we have to determine whether x is a prime number. So let us evaluate the statements one by one. Statement 1 says that x, y square is equal to 116. So let us do the prime factorization of 116. 116 is equal to 2 square into 29. So looking at x, y square and 2 square into 29, it is clear that y square is equal to 2 square and x is equal to 29. Since 29 is a prime number, statement 1 alone is sufficient to answer whether x is a prime number or not. Now let us look at statement 2. Statement 2 says that xz is equal to 261. So let us do the prime factorization of 261. 261 is equal to 3 square into 29. So there can be many cases for x and z. X is equal to 9 and z is equal to 29. X is equal to 29 and z is equal to 9. X is equal to 3 and z is equal to 87. X is equal to 87 and z is equal to 3. Now, in some cases x is prime and in other cases x is not prime. Like in the first case x is not prime, in the second case it is prime, in the third case it is prime, in the fourth case it is not prime. So statement 2 is not sufficient to answer the question. Therefore the correct answer is option A. Statement 1 alone is sufficient while statement 2 alone is not sufficient to determine whether x is a prime number. We have 7 persons A, B, C, D, E, F and G and they travel by 3 cars X, Y and Z. We are given few cues and based on them we have to identify the correct statements. So let us read the cues. A and another 2 of them travel by X. So X has A and another 2 people in it. Only E travels with G. This means that E and G travel only with each other. So E and G can be in Y or Z. Now let us read the next statement. C travels by Z but B does not travel by Y. So C travels by Z. So if C travels by Z, E and G cannot be in Z. So let us remove Z from here. B does not travel by Y. This means that B travels by X or B travels in Z. Now let us read the next statement. Besides, A and B do not travel by the same car. This means that B cannot travel in X since A is traveling in X. So B travels in Z with C. This leaves us with D and F. So D and F travel with A in X. Now we have the arrangements. Now let us read the statements. Statement 1 says that no one travels alone. So this statement is correct. Statement 2 says that only D travels with F. So this statement is not correct since A, D and F travel together. Statement 3 says that only C travels with B. So this statement is again correct. So the correct answer is 1 and 3 and the correct option will be option B. For 1 by 3 less than x less than y less than 2, which of the following statements is or are always correct? So first statement is x plus 1 by x is less than y plus 1 by y. Since x is less than y, let us take x as 1 by 2 and y as 3 by 2. So x plus 1 by x will become 1 by 2 plus 2, which is equal to 2.5. And y plus 1 by y will become 3 by 2 plus 2 by 3. So 3 by 2 is 1.5 and 2 by 3 is 0.67. So this comes out to be 2.17. Since 2.5 is not less than 2.17, statement 1 is not correct. Now let us look at statement 2. Statement 2 says that under root of 1 plus y square upon y is less than under root of 1 plus x square upon x. Since x and y are both positive, we can square both sides without changing the sign of the inequality. So squaring both sides we get 1 plus y square upon y square is less than 1 plus x square upon x square. Simplifying it further we get 1 upon y square plus 1 is less than 1 upon x square plus 1. Cancelling 1 on both sides we get 1 upon y square is less than 1 upon x square. Now we know that x is less than y. So 1 upon x square will always be greater than 1 upon y square. So this is same as this. Hence statement 2 is always correct. And the correct option is option B, statement 2 only. A person saves 10% of his salary every month. If his salary increases by 12% and the expenditure increases by 10%, then what will be the change in his saving per month? Since it is a percentage based question, we'll assume the initial salary to be rupees 100. He saves 10% of his salary, so his initial savings will be rupees 10. Rupees 10 is 10% of 100. So his expenditure will become 100 minus 10, which is equal to 90. Now it is given that his initial salary increases by 12%. So 12% of 100 will be 1.12 into 100 and that is equal to 112. His expenditure increases by 10%. So 10% of 90 will be 1.1 into 90 and this is equal to 99. So his new savings will become 112 minus 99. So this is equal to 13. Now the question is asking what will be the change in his saving per month. So percentage change in saving will be 13 minus 10 upon 10 into 100. New savings minus initial savings upon initial savings into 100. So this is equal to 30%. Hence the correct option is option B. We are given a few statements about W, X, Y and Z and we have to identify which of these two statements is or are correct. So let us read the statements. If X is incorrect, then so is Z. If X is incorrect, then Z is also incorrect. If Y is incorrect, then W is correct. If Y is incorrect, then W is correct. If W is correct, then X is incorrect. If W is correct, then X is incorrect. Now let us draw a chain out of this. We have W correct here and we have W correct here. So we can write it as, if Y is incorrect, then W is correct. And if W is correct, then X is incorrect. So let us write X incorrect here. If X is incorrect, then Z is incorrect. So let us write Z incorrect here. So we have our chain here and we'll use this chain to analyze both these statements. Statement 1 says that if X is correct, then so is Y. So from the chain we can say that if Y is incorrect, then X is also incorrect. So let us write it down. If Y is incorrect, then X is incorrect. We can also write the opposite. If X is correct, then Y is also correct. Because if Y is incorrect, then X will be incorrect. So X correct guarantees Y correct. Hence statement 1 is correct. Let us read the next statement. If Z is correct, then it is not necessary that Y is correct. So in our chain, we can see that if Y is incorrect, then Z is incorrect. So let us write it down. If Y is incorrect, then Z is incorrect. And let us also write the opposite, which will be true. If Z is correct, then Y is correct. Because if Y is incorrect, Z will be incorrect. Hence, Z correct guarantees Y correct. So statement 2 is wrong. So the correct option is option A, 1 only. So let us first understand what is happening in the question. X and Y are two runners who are running on a circular track. They begin at the same point and start running in the same direction. When X completes 7 rounds, Y completes 5 rounds. It is given that after 5 rounds, Y changes his direction and doubles his speed. And X continues to run with the same speed. They stop running when X completes 21 rounds. So the question is asking how many times did X and Y meet after they had started and before they finally stopped. Before we solve, let us understand the circular trick. So it says that if there are two runners on a circular track and their speeds are in the ratio A is to B, where A and B are co-prime means they don't have any common factor other than 1, then if they're running in the same direction, they will have A minus B meeting points on the circular track, or they will have A minus B meetings till the time they reach the starting point. And if they're running in the opposite direction, they will have A plus B meeting points on the circular track, or they will have A plus B meetings till the time they come to the starting point. It is given that when X completes 7 rounds, Y completes 5 rounds. Let us suppose that X takes 1 hour to complete 7 rounds. So speed of X will be 7 laps per hour. Lap is 1 round. And speed of Y will be 5 laps per hour. The ratio of their speeds will be 7 is to 5. 7 and 5 are co-prime numbers. So this means that they will meet for 7 minus 5 times. That is, they will have 2 meetings. It is given that after Y completes 5 rounds, that is after 1 hour, Y changes his direction. We are taking 1 hour because speed of Y is 5 laps per hour. So after 1 hour, Y changes his direction and doubles his speed. So X's speed will remain same. It will be 7 laps per hour and Y's speed will become 10 laps per hour. This means that X covers 7 laps in an hour and Y covers 10 laps in an hour. So they meet after 1 hour after covering 7 and 10 laps. The ratio of their speeds will be 7 is to 10. 7 and 10 are co-prime numbers. Hence we can use this formula. So in 1 hour they will meet for 7 plus 10 times, which is equal to 17. They stop running when X completes exactly 21 rounds. So speed of X is 7 laps per hour. So he will cover 21 laps in 3 hours. So for the first hour they move in the same direction, and in the next 2 hours they move in the opposite direction. So if they meet for 17 times in the second hour, they will meet for 17 times in the third hour as well. So in total they will meet for 2 plus 17 times, and that is equal to 36 times. But since the question is asking how many times did X and Y meet after they had started and before they finally stopped, so we'll have to exclude the last meeting. So we'll subtract 1 from this, and so the answer is 35. The correct option is option A. A train has to cover 800 kilometers. If it meets with a minor accident, the speed becomes half of the existing speed. And if it develops a mechanical defect, its speed becomes 1/4 of the existing speed. So on its way, the train meets with a minor accident after 200 kilometers, and 400 kilometers later, it develops a mechanical defect. Had the train developed the mechanical defect after 200 kilometers and met with the minor accident 400 kilometers later, it would have taken 4 more hours to reach the destination. Now the question is asking us the original speed of the train. So let us solve the question. Let the initial speed of the train be x. So in the first case, for the first 200 kilometers, the speed is x. After that, the train meets with a minor accident. Hence, the speed becomes half of the existing speed. So it will be x by 2. This continues for 400 kilometers, and after that, the train develops a mechanical defect. Hence, the speed will be 1/4 of the existing speed. So it will be 1/4 of x by 2. Hence, it will be x by 8. This continues for the remaining 200 kilometers. Hence the time taken will be t1 will be equal to 200 by x plus 400 by x by 2 plus 200 by x by 8. So this is equal to 200 by x plus 800 by x plus 1600 by x. So this is equal to 2600 by x. In the second case, for the first 200 kilometers, the speed is x. After that, the train develops a mechanical defect, hence the speed becomes 1/4 of the existing speed. So the speed will become x by 4. This continues for 400 kilometers. After that, the train meets with a minor accident. Hence the speed becomes half of the existing speed. So it becomes x by 8. This continues for the remaining 200 kilometers. Hence T2 will be equal to 200 by x plus 400 by x by 4 plus 200 by x by 8. So this is equal to 200 by x plus 1600 by x plus 1600 by x. So this is equal to 3400 by x. It is also given that T2 minus T1 is equal to 4. So 3400 by x minus 2600 by x is equal to 4. 800 by x is equal to 4. X is equal to 800 by 4, which is equal to 200. So the initial speed of the train is 200 km per hour. Hence the correct option is option A. First, let me briefly explain the question. So we have three types of tiles of dimensions 3 by 3, 3 by 7 and 3 by 11. Using these tiles, we need to exactly cover a 3 by 100 rectangle without breaking any tile. So we have to find the maximum and the minimum number of tiles that can be used. The maximum value is x and the minimum value is y. We need to find what is x minus y. Now let us visualize the problem. Notice that every tile has the same width of 3 and even the rectangle has the same width 3. This means the width is already covered and we only need to arrange the tile lengths 3, 7 and 11 to make a total of 100. So we can write this as 3a plus 7b plus 11c is equal to 100. A is the number of tiles with length 3, B is the number of tiles with length 7 and C is the number of tiles with length 11. And A plus B plus C is the number of tiles. The maximum value of n is x and the minimum value of n is y. Now let us find the maximum value of n, which is x. To maximize the number of tiles, we'll have to use the smallest tile as much as possible. So we'll use the 3-foot tile. But if we use only the 3-foot tile, then 33 tiles will cover 99 feet, but 1 foot will still be left uncovered. So to cover that extra 1 foot, we'll replace 2 3-foot tiles with 1 7-foot tile. So the total number of tiles will become 32. 31 3-foot tiles and 1 7-foot tile. So x is equal to 32. Now let us find the minimum number of tiles. So minimum number of tiles is y. To minimize the number of tiles, we'll have to use the largest tile as much as possible. So if we use only the 11-foot tiles, then 9 tiles will cover 99 feet and 1 foot will again be left uncovered. So let us use 8 11-foot tiles, so that will cover 88 feet and the remaining 12 feet can be covered by using 4 3-foot tiles. So y becomes 8 plus 4. 8 is the number of 11-foot tiles and 4 is the number of 3-foot tiles. So y becomes 12. Now we are asked to find the value of x minus y. So 32 minus 12 is equal to 20. Hence the correct option is option A. So this is a subset based reasoning question. We are given a few statements and based on them we have to identify which of the conclusions P, Q and R are correct. So let us read the statements one by one. Every red is blue. This means red is a subset of blue. We can represent this using circles. So red lies inside blue. Now let's read the next statement. Every blue is green. This means blue is a subset of green and blue lies inside the green circle. Now let's read the last statement. Every green is yellow. This means green is a subset of yellow and the green circle lies inside the yellow circle. Now let's verify the conclusions. P says every blue is yellow. So blue lies inside the yellow circle. Hence this statement is correct. Let's read the next statement. Every red is green. So red lies inside the green circle. Hence this statement is also correct. Now let's read the last statement. Every red is yellow. So red lies inside the yellow circle. Hence this statement is also correct. So all the three statements P, Q and R are correct. Hence the correct option is option D. So this is a relation based question. Some cues are given. We have to connect the cues and then answer the question. So let's read the cues one by one. P has a son and a daughter. So let's draw the family tree. P has a son and a daughter. So let's put M for male and F for female. M is for the son and F is for the daughter. Let's read the next cue. S is the mother of T. So S is the mother of T. Since S is a mother, let's put F here. F for female. S is R's spouse. So S is married to R. So R must be a male. So let's put M here. Q and R are children of P. So since R is a male, R must be the son and Q must be the daughter. Then how is Q related to S? So Q is the sister of R who is married to S, who is the mother of T. So Q is the sister of the husband of S. Hence the correct answer is option D. First, let us briefly understand the question. The question tells us that every cut divides an object into two parts and a single cut can be used to cut more than one object at a time. It also defines xn as the total number of pieces after n cuts. So x3 is the number of pieces after 3 cuts and x4 is the number of pieces after 4 cuts. Now an experiment is performed on a cube where the pieces remain unmoved after every cut. The important condition is that after the third cut, all the pieces are identical. Our task is to find which value of x4, that is the number of pieces after 4 cut, is not possible. So let us solve it. Since the pieces after the third cut have to be identical, I have already drawn the possible arrangements of the first 3 cuts. So the first case produces 8 identical objects, the second case produces 6 identical objects, and the third case produces 4 identical objects after the third cut. The black lines represent the first 3 cuts, and now let us draw the fourth cut shown by the red line. So let us look at the first figure. I want you to visualize this carefully. Here, the first 3 cuts divide the cube into 8 identical pieces. Now let me draw the fourth and final cut. The fourth cut passes through 4 cubes, dividing each of them into 2. So the total number of pieces now become 12. I want you to visualize this carefully to understand the question. Now look at the second figure. Here, the first 3 cuts divide the cube into 6 identical pieces. Now let me draw the fourth and final cut. Here, the fourth cut passes through 2 of these pieces. Now the total pieces become 8. Please visualize this carefully, take your time. And now let's look at the third figure. Now finally visualize this arrangement. Here the first 3 cuts produce 4 equal slabs. Now let me draw the final cut. The fourth cut divides one of the slabs, so the total number of pieces become 5. So the possible values of x4 are 12, 8 and 5. There are no other possible values. Since 16 is not among these values, it is not a possible value of x4. Hence the correct option is option A. So before solving, let me first explain the question. There are 7 identical cubes. Only one cube is lighter while the other 6 have the same weight. Using a balance, we have to identify the lighter cube in the minimum number of weighings. So the question has asked us the minimum number of weighings required. So let the cubes be A, B, C, D, E, F and G. First we'll weigh 3 cubes against the next 3 cubes. So let us weigh A, B, C versus D, E, F and let's keep G aside. Now if both sides balance, then all 6 cubes are equal. So the remaining cube G will be the lightest. Now if they don't balance, the lighter cube must be among the 3 cubes on the lighter side. So suppose A, B, C weighs lighter than D, E, F. So we'll take this group and we'll weigh A versus B and we'll keep C aside. Now if A and B balance, if they are equal in weight, that would mean that C is the lightest cube. And if they don't weigh equally, then the lighter cube must be the lightest cube among the 7 cubes. So we'll require 2 weighings to distinguish the odd cube with certainty. Hence the correct answer will be option A. So an explosion occurs at some distance from an army camp. As soon as the camp hears the sound, first drone starts moving towards the explosion site. As soon as it reaches the site, it clicks a picture and the picture is immediately received at the camp at 5:02 p.m. Immediately after receiving this picture, second drone starts moving towards the same site. As soon as it reaches there, it clicks a picture and the picture is immediately received at the camp at 5:05 p.m. Now the speed of each drone is given as 30 meters per second and speed of sound is 300 meters per second, and we are asked to find the time of the explosion. So let the distance between the army camp and the explosion site be d. It is known that the second picture is received at 5:05 p.m. and the first picture is received at 5:02 p.m., which is when the second drone starts moving towards the explosion site. This means that the second drone takes 3 minutes to reach the explosion site. So let's calculate the distance between the explosion site and the army camp. Distance is equal to speed into time. Speed of the drone is 30 meters per second and the time taken by the drone is 3 minutes or 180 seconds. So the distance between the army camp and the explosion site is 5400 meters. Now let's calculate the time taken by the sound to reach the army camp. So time is equal to distance upon speed. Distance is 5400 meters and the speed of sound is 300 meters per second. So this gives us 18 seconds. This means that after the explosion, the camp waits 18 seconds to hear the sound. Then the first drone flies for 180 seconds or 3 minutes before reaching the explosion site. So the first picture is received after 18 plus 180 seconds, which is equal to 198 seconds or 3 minutes 18 seconds. This is the time that we need to subtract from 5:02 p.m. So this gives us 4:58 and 42 seconds p.m. So the correct answer is option C. There are 7 identical cubes. Only one cube is lighter while the other 6 have the same weight. Using a balance, we have to identify the lighter cube in the minimum number of weighings. So the question has asked us the minimum number of weighings required. So let the cubes be A, B, C, D, E, F and G. First we'll weigh 3 cubes against the next 3 cubes. So let us weigh A, B, C versus D, E, F and let's keep G aside. Now if both sides balance, then all 6 cubes are equal. So the remaining cube G will be the lightest. Now if they don't balance, the lighter cube must be among the 3 cubes on the lighter side. So suppose A, B, C weighs lighter than D, E, F. So we'll take this group and we'll weigh A versus B and we'll keep C aside. Now if A and B balance, if they are equal in weight, that would mean that C is the lightest cube. And if they don't weigh equally, then the lighter cube must be the lightest cube among the 7 cubes. So we'll require 2 weighings to distinguish the odd cube with certainty. Hence the correct answer will be option A. The class average X in a test increases by 4 when the score of a student is rectified whose corrected score is 100 instead of 0. Later, the score of another student was found to have been recorded as 81 in place of 56. If there are no other corrections and the final corrected average is Y, then Y minus X is. So let's understand the question. Here, 2 mistakes have been made while recording the marks. The first mistake is to mark the marks as 0 instead of 100. So the correction will be 0 to 100. And the second mistake was to record the marks as 81 instead of 56. So the second correction will be from 81 to 56. Now we simply have to find how much the average changes after both the corrections. So let's first understand the concept that we are going to use here. So the concept is change in average is equal to change in marks upon number of total students. So change in average in the first case is given as 4 and change in marks is 100. So 100 upon n. N is equal to 25. So this gives us the total number of students in the class, which is 25. Now let's see the second case. In this, change in average is equal to change in marks. So 56 minus 81 gives us minus 25 upon number of students. So number of students is 25. So change in average is minus 1. So first the average increases by 4. So it becomes x plus 4 and then it reduces by 1. So x plus 4 minus 1. So this gives us the final average, which is y. So x plus 3 is equal to y. So y minus x is equal to 3. So this is what the question asks. Hence the correct option is option B. So x, y and z jump forward 4 feet, 6 feet and 5 feet respectively. At 8 am they all land on the 199 feet mark. How many times will they all land on the same mark need not be at the same moment between 195 feet mark and 1000 feet mark if all of them cross the 1000 feet mark by 9 am. So let me explain the question first. All the 3 x, y and z start from 199 feet mark at 8 am. Also, x jumps 4 feet, y jumps 6 feet and z jumps 5 feet at a time. We have to find the common landing marks between 195 feet and 1000 feet. Now it is given that they start at 8 am and end at 9 am. This information is irrelevant to the question asked, since the question itself mentions that they need not be at the same point at the same moment. So we only care about where they land and not when they land. So let's solve the question. X, y and z start from 199 feet mark and the gap between the common landing marks must be divisible by 4, 5 and 6 for them to land on the same point. So let's take the LCM of 4, 5 and 6. This is equal to 60. This means that the common landing marks form an AP with the first term as 199 and the common difference as 60. Now by using the AP formula, A plus n minus 1 D should be less than 1000. This means that 199 plus n minus 1 into 60 should be less than 1000. This gives us n minus 1 into 60 should be less than 801. N minus 1 should be less than 801 by 60, which is equal to 13.35. N minus 1 should be less than 13.35. N should be less than 14.35. Since n is a whole number, n will be 14. So this means that the correct answer is option D. There are 4 types of weights: 1 kg, 2 kg, 5 kg and 10 kg. What is the maximum number of different ways one can measure 20 kg if at least 8 but not more than 11 weights of 1 kg are to be used while measuring? So let me explain the question first. The question says that there are 4 types of weights: 1 kg, 2 kg, 5 kg and 10 kg. And we need to measure 20 kg of weight. The only condition is that the number of 1 kg weight should be at least 8 and at most 11. Now we need to find the maximum number of different ways this can be done. So there are 4 cases in which the number of 1 kg weights are 8, 9, 10 and 11. Now for each of these cases, we'll find the number of weights. So when the number of 1 kg weight is 8, the remaining weight is 12. So we can have 6 2 kg weights. So 6 into 2 gives us 12. We can also have 1 2 kg weight and 2 5 kg weight. So 2 plus 5 plus 5. We can also have 1 2 kg weight and 1 10 kg weight. So 2 plus 10. There are no other possibilities under this case. So the total number of possibilities in this case is 3. Now let's take the next case. When the number of 1 kg weights is 9, the remaining weight is 11. So we can have 3 2 kg weights. So 3 into 2 plus 1 5 kg weight. So, and there are no other possibilities under this case. So the number of possibilities is 1. Now let's check the third case. When the number of 1 kg weights is 10, the remaining weight is 10. So we can have 5 2 kg weights. So 5 into 2. We can also have 2 5 kg weights. So 5 plus 5. We can also have 1 10 kg weight. So the total number of possibilities under this case is 3. Now let's check the last case when the number of 1 kg weights is 11. So the remaining weight will be 9. So we can have 2 2 kg weights, 2 plus 2 and 1 5 kg weight. So 2 plus 2 plus 5. We don't have any other possibilities under this case. So the number of possibilities under this case is 1. So the total number of possibilities will be 3 plus 1 plus 3 plus 1. This gives us 8. Hence the correct option is option B. So let me explain the question first. 8 persons P, Q, R, S, T, U, V and W sit around a round table in 8 seats that are equally spaced. Now we are given some clues and we are asked that how many persons shall Q cross while moving in the clockwise direction before meeting W. So let's read the clues. Both P and R are adjacent to Q. This means that Q will be in the middle and P and R will be on the sides. So let's place P on the left and R on the right. We can have another scenario in which Q is in the middle and P is on the right and R is on the left. Now let's read the next clue. Both T and R are adjacent to S. This means that S will be in the middle and T and R will be on its sides. We have R fixed. So let's place S in the middle and let's place T next to it. Now let's read the next clue. Both U and W are adjacent to V. Since we do not have the locations of U, V or W, let's skip the step for now and move on to the next step. So S and W are on the opposite chairs. We have the location of S fixed. Let's place W on the opposite end. Now let's move back to the previous clue that we had earlier skipped. So both U and W are adjacent to V. So we have the location of W fixed. Let's place V in the middle and U on its sides. V in the middle and U on its side. Now let's read the next clue. If while going in the clockwise direction around the table from P, one meets R before T. So let's start from P. We are going in the clockwise direction. We meet R before T. So this scenario is valid. Let's check the other scenario. We are starting from P in the clockwise direction. We are meeting T before R. So this scenario is not valid. Now let's read the question. How many persons shall Q cross while moving in the clockwise direction before meeting W? So let's start from Q. We meet R, S, T, U, V before meeting W. So we have 5 persons before we meet W. So the correct option is option A. So the weights of A, B, C, D, P, Q, R and S are given in the form of equations and we have to answer which of these 4 statements is correct. So A plus B plus C plus D equals 17. This is equation 1. A plus C equals 6. This is equation 2. P plus Q plus S plus D is equal to 15. So this is equation 3. P plus Q plus R plus B is equal to 17. This is equation 4. P equals R. This is equation 5. Q equals S. This is equation 6. Now the question asks which of these 4 statements is correct. So let's start solving. Let's subtract equation 2 from equation 1. So 1 minus 2 gives us B plus D is equal to 17 minus 6 which is equal to 11. So let this be equation 7. Now let's see equation 3 and equation 6. According to equation 6, Q is equal to S. So let's substitute this value into equation 3. So P plus Q plus D is equal to 15, which means P plus 2Q plus D is equal to 15. Let this be equation 8. Now let's see equation 4 and equation 5. According to 5, P is equal to R. So let's substitute the value of R in equation 4. So P plus Q plus P plus B is equal to 17. This means 2P plus Q plus B is equal to 17. Let this be equation 9. Now let's add equation 8 and equation 9. So this gives us 3P plus 3Q plus D plus B is equal to 15 plus 17 which is equal to 32. This means 3P plus Q plus B plus D is equal to 32. Now we know from equation 7 that B plus D is equal to 11. So 3P plus Q plus 11 is equal to 32. This means 3P plus Q is equal to 21 which gives us P plus Q as 7. So let this be equation 10. Now let's check the statements. B plus D together weigh less than the total weight of P and Q. So the total weight of P and Q is equal to 7 and B plus D is equal to 11. So B plus D weigh more than P plus Q. Hence statement A is wrong. Now let's check the statement B. P and Q together weigh more than total weight of A and C. So P plus Q is equal to 7 and A plus C is equal to 6 according to equation 2. So this statement is correct. P plus Q is equal to 7 and A plus C is equal to 6. So the correct answer is option B. The top of a table is rectangular and its dimensions are 6 feet by 10 feet. Two rectangular portions of the tabletop are painted in blue color. Both these portions have dimensions 2.5 feet by 8 feet and each of them has exactly two sides common with two edges of the tabletop. If the table is fixed to the ground and the remaining portion of the tabletop is painted in white, how many different patterns are possible when observed from above? So there is a rectangular table of size 6 feet by 10 feet and there are two blue rectangular portions of size 2.5 feet by 8 feet and each blue portion is placed on the table such that they touch exactly two sides of the table and the remaining portion is painted white and the rectangular portions are painted blue. Now the question asks how many such different patterns are possible. Note that the 8-foot length of the rectangular patch can be accommodated only along the 10-foot length of the rectangular table. Also, each 10-foot length of the table can occupy only one rectangular patch. This means one rectangular patch will be on the top and the other one will be on the bottom. And the top one can occupy either the left side or the right side. So, there are two possibilities for the top side and similarly there are two possibilities for the bottom side. And the total number of possibilities will be 2 into 2. So, the correct answer is 4. And the correct option is option B. X travels 6 km on a bike with average speeds of 5 km per hour, 10 km per hour and 4 km per hour during the first 1 km, the next 2 km and the remaining 3 km respectively. Y travels the same distances with average speeds of 4 km per hour, 10 km per hour and 5 km per hour respectively. How many minutes early will Y complete the journey if both X and Y start at the same time? So the distance segments are 1 km, 2 km and 3 km. Speed of X for each segment is 5 km per hour, 10 km per hour and 4 km per hour. For Y we have 4 km per hour, 10 km per hour and 5 km per hour. So we know that the time is equal to distance upon speed. So let's calculate the time for each segment. So for the first segment, the time is 1 by 5 for X, 2 by 10 and 3 by 4. So the total time is 1 by 5 plus 2 by 10 plus 3 by 4. So the LCM of the denominators is 20. So let's calculate the total time. So it is equal to 4 plus 4 plus 15. So it is equal to 23 by 20 hour. Now let's calculate the time for each segment for Y. So we have 1 by 4, 2 by 10 and 3 by 5. So let's calculate the total time. The LCM of the denominators is again 20. So we have 5 plus 4 plus 12. So it is equal to 21 by 20. Now we are asked how many minutes early will Y complete the journey. So that is equal to the difference between the two times. So it will be equal to 2 by 20. So let's convert it into minutes. So 2 by 20 into 60 minutes. So simplifying this we get answered as 6 minutes. So the correct option is option D.
The question goes like this. A toy T jumps forward or backward. In each forward jump, it moves 5 feet forward, whereas in each backward jump, it moves 2 feet backward. If in 31 jumps, T moves exactly 15 feet forward, then what is the difference of the number of forward and backward jumps? So let's consider the number of forward jumps as F and the number of backward jumps as B. The total number of jumps would then be F plus B, which is given as 31. This will be our equation number 1. The distance covered by the forward jumps will be 5F and the distance covered by the backward jumps will be 2B. The total distance hence covered will be 5F minus 2B, which is given as 15. This is our equation number 2. Solving these two equations, we will get our answer. So from equation number 1, we get F as 31 minus B. Now substituting this value into second equation, we get 5 into 31 minus B minus 2B is equal to 15. 155 minus 5B minus 2B is equal to 15. 140 minus 7B is equal to 0. 7B is equal to 140. B is equal to 20. Substituting this value in equation 1, we get F plus 20 is equal to 31. Hence, F would be 11. Now we have been asked the difference between the number of forward jumps and the backward jumps. So our answer will be 20 minus 11, which is 9. So option D is the correct answer.
how many 3-digit numbers can be expressed as an integral power of 2? So we have been asked powers of 2 that are between 100 and 999. So we'll begin by writing the powers of 2. 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, and so on. So we can see that there are only three 3-digit numbers that can be expressed as powers of 2, and they are 128, 256, and 512. So the correct answer is 3, and the correct option is option C. If 10 to the power m into 1000 into n is equal to 75 to the power 25 into 25 to the power 32 into 32 to the power 75, where n is not divisible by 10, then the value of m is. So for this, we'll simplify both the LHS and RHS and then equate the powers of 10 to get the value of m. So LHS is 10 to the power of m into 1000 into n. It can be written as 10 to the power of m into 10 to the power of 3 into n, and it can be written as 10 to the power of m plus 3 into n. RHS is 75 to the power 25 into 25 to the power 32 into 32 to the power 75. It can be written as 3 into 5 square to the power 25 into 5 square to the power 32 into 2 to the power 5 to the power 75. This can be written as 3 to the power 25 into 5 to the power 50 into 5 to the power 64 into 2 to the power 375. It can be further simplified as 3 to the power 25 into 5 to the power 114 into 2 to the power 375. Since 5's power is less than 2's power, 5 is the limiting factor, hence we'll equate the power of 5 on the RHS with the power of 10 on the LHS. So m plus 3 is equal to 114. Hence m is equal to 111, and our correct option is option B. The speed of a train T is 100 km per hour and the speed of a person P is 4 km per hour. T crosses P in 15 seconds if P travels along the direction of motion of T. If P travels along the opposite direction of T, then in how much time does T cross P in seconds? So let's solve it. Let the relative speed of train T with respect to person P when they both travel in the same direction be S1. So S1 is equal to speed of train minus speed of person. This is equal to 100 minus 4, which is equal to 96 km per hour, which can also be written as 96 into 5 by 18 meters per second. Now let the relative speed of train T with respect to person P when they both travel in the opposite direction be S2. So S2 is equal to speed of train plus speed of person, which is equal to 100 plus 4, which is equal to 104 km per hour, or 104 into 5 by 18 meters per second. We also know that S1 into T1 is equal to S2 into T2, which is equal to length of the train, where T1 is the time taken by the train to cross the person P when they're traveling in the same direction, and it is given as 15. And T2 is the time taken by the train to cross the person P when they're traveling in the opposite direction, and we have to find the value of T2. By substituting the values, we get 96 into 5 by 18 into 15 is equal to 104 into 5 by 18 into T2. We'll cancel 5 by 18 on both the sides, and solving for T2 we get T2 is equal to 96 into 15 by 104, and we'll divide the numerator and denominator both by 8, so we get 12 in the numerator and 13 in the denominator, and T2 is equal to 12 into 15 by 13, which is equal to 180 by 13, and it is close to 13.85. So our answer is option C. P, Q, R, S, and T are ranked 1 to 5, not necessarily in that order. Let's create a table for this since it's a rank question. 1, 2, 3, 4, 5. The rank of P is 4. Let's place P in the 4th position. The rank of Q is not 5. Let's put not Q in the 5th position. The rank of R is 1. Let's place R in the 1st position. The rank of S is not 2. Let's put not S in the 2nd position. The rank of T is not 3. Let's put not T in the 3rd position. So let's place all the letters which can occupy the 2nd, 3rd and 5th position. So the 2nd position can be occupied by Q and T. The 3rd position can be occupied by S and Q. And the 5th position can be occupied by S and T. Now we need to create another table
since we need to test different possibilities and verify statements separately. So I'm just duplicating this table.
Now let's verify each statement separately. The first statement goes like this. If the rank of S is 3, then that of T is 2. So in the first table, let's put S in the third position. So we'll remove Q. If we remove Q from the third position, we see that Q occupies the second position and T occupies the fifth position. So first statement is wrong, since if the rank of S is 3, the rank of T is 5. Now let's read the second statement. If the rank of Q is 3, then that of T is 5. So in the second table, let's put Q in the third position. Now if we put Q in the third position, T will be in the second position and S will be in the fifth position. So statement 2 is also wrong, because if the rank of Q is 3, the rank of T is 2. So our answer is D, neither 1 nor 2. The digit in the unit place of the number 6 to the power 129 into 7 to the power 307 is. We'll solve this question in two parts. First, we'll find the unit digit of 6 to the power 129. Then we'll find the unit digit of 7 to the power 307. So any power of 6 will always end in 6. And now we'll find the unit digit of 7 to the power 307. We'll start by writing the unit digits of powers of 7. So 7 to the power 1 is 7. 7 to the power 2 is 49. The unit digit is 9. 7 to the power 3 is 343. The unit digit is 3. 7 to the power 4 is 2401. Unit digit is 1. Since 7 to the power 4 ends in 1, the cycle will repeat again and the unit digits will follow a pattern of 7, 9, 3, 1, 7, 9, 3, 1 and so on. Also, 307 when divided by 4 leaves a remainder of 3. Hence, 7 to the power 307 will end in the same digit as 7 to the power 3, which is equal to 3. Now we'll multiply both the digits. 6 into 3 is equal to 18. The unit digit is 8. Hence, the given number 6 to the power 129 into 7 to the power 307 will end in 8, and the correct answer is option C. If x and y are two digits and the number 4x5y790 is divisible by 11, then what is the remainder if x plus y is divided by 11? So let's write down the number and apply the divisibility rule of 11. 4x5y790. According to the divisibility rule of 11, if a number is divisible by 11, the sum of digits at odd places when subtracted from sum of digits at even places results in a number that is a multiple of 11. So let's mark the digits at odd and even places. Odd, even, odd, even, odd, even, odd. Now applying the divisibility rule of 11, we get x plus y plus 9 minus 4 plus 5 plus 7 plus 0 is a multiple of 11, that is 11k. Hence, x plus y plus 9 minus 16 is 11k. Hence, x plus y minus 7 is 11k. We also know that x and y are single digits. So, x plus y can have a value from 0 to 18. Therefore, x plus y minus 7 has a range from minus 7 to 11. Now, the only values that are a multiple of 11 are 0 and 11. So, x plus y minus 7 can be 0 or x plus y minus 7 can be 11. Therefore, we get x plus y is equal to 7 in the first case and x plus y is equal to 18 in the second case. Now, in the first case, when we divide the value of x plus y by 11, we get the remainder as 7. In the second case, when we divide the value of x plus y by 11, we get a remainder of 7 as well. So, in both the cases, we get a remainder of 7. Hence, our answer is option D. The ratio of male to female workers in two companies A and B is 13:10 and 7:5 respectively. If both the companies have the same number of female workers, then what is the ratio of the total number of workers in A to those in B? So let's assume the total number of workers in company A be X and in company B be Y. We have been asked the ratio of X by Y. It has been given that the male to female ratio in company A is 13:10 and male to female ratio in company B is 7:5. So in company A, the total parts are 23. Hence, the number of female in company A will be 10 by 23x. The total parts in company B is 12. So the number of females in company B will be 5 by 12y. It has also been given that in both the companies, the number of females are equal. So 10 by 23x is equal to 5 by 12y. Hence, x by y is equal to 5 by 12 into 23 by 10. Simplifying this, we get x by y is equal to 23 by 24. Hence, the correct answer is 23 by 24 and the correct option is option B. An alloy P contains 20% copper and 80% zinc by weight. Another alloy Q contains 60% copper and 40% zinc by weight. A third alloy R is to be prepared from P and Q so that it contains equal amount of copper and zinc. In what ratio amounts of P and Q be mixed in order to get R? So P contains 20% copper and Q contains 60% copper. Now the required alloy R contains equal amount of copper and zinc. Hence R contains 50% copper. Now in such questions, we use the alligation cross method where we find the differences diagonally. So 50 minus 20 gives us 30 and 60 minus 50 gives us 10. Now these differences become the mixing ratio. So P is to Q is equal to 10 is to 30. Now this when simplified gives us 1 is to 3. Hence the correct answer is option A. A is a 2-digit number with different digits. P is also a 2-digit number and is obtained by reversing the digits of A. If A minus B is a multiple of 27, where A is greater than B, how many such different A's are possible? So let's assume A to be 10x plus y, where x is the 10th digit and y is the unit digit. Then B will be 10y plus x. It has been given that these two digits are different, so x is not equal to y. Since B is also a 2-digit number, y cannot be equal to 0. So y is not equal to 0. X is anyway not equal to 0. So it has been given that A is greater than B. So 10x plus y is greater than 10y plus x. Simplifying this, we get 9x is greater than 9y, which gives us x is greater than y. Also, it has been given that A minus B is a multiple of 27. So A minus B is equal to 27k, where k is any integer. So 10x plus y minus 10y plus x is equal to 27k. 9x minus 9y is equal to 27k. Simplifying this, we get x minus y is equal to 3k. So x minus y is a multiple of 3. So the difference between x and y can be 3, it can be 6, or it can be 9. So we'll find the possibilities of x and y in each of the 3 cases. So when x minus y is equal to 3, x and y can assume the values of 3, 0, 4, 1, 5, 2, 6, 3, 7, 4, 8, 5, and 9, 6. Now let's take the second case where x minus y is equal to 6. So x and y can assume the values of 6, 0, 7, 1, 8, 2, and 9, 3. Now let's take the last case. X minus y is equal to 9. So x and y can take the values of 9 and 0. So we have already established that x and y cannot be 0. So we'll eliminate the possibilities where y is equal to 0. So in the first case, we'll eliminate this. In the second case, we'll eliminate this. And in the third case, we'll eliminate this. Now let's count the number of possibilities of x and y. 1, 2, 3, 4, 5, 6, 7, 8, 9. So A can have 9 possible values. So the correct answer is option B. If 0 is encoded as ADSN, then how do you encode stop? So the first step is to identify the pattern used in coding. We'll start by writing the letters Z, E, R, O. So Z becomes A, which means we are moving one letter forward. So the operation is +1. E becomes D. So we are moving one letter backwards. So the operation is -1. R becomes S. So the operation is +1. O becomes N. So the operation is -1. Now we'll apply the same operations on the letters of the word stop. So S, T, O, P. +1 gives us T, -1 gives us S, +1 gives us P, -1 gives us O. So the correct answer is option B. 3 variables x, y and z take values 2, 3, 4 or 5 such that their values are always distinct.
If m and n denote the largest possible value and the smallest possible value respectively for the expression x into y plus z, then m minus n is, so we'll write down the expression first, x into y plus z. Also, x, y, and z belong to a set containing 2, 3, 4, and 5. X, y, z are distinct values. Now we'll find the value m, which is the maximum value of the expression. So for the maximum value, we'll put the largest numbers in the product and then add the larger remaining number. So the largest two numbers are 5 and 4. So 5 into 4 plus, now we'll add the larger remaining number, which is 3. So this gives us 20 plus 3, which is equal to 23. Now we'll find n, which is the smallest possible value of the expression. So for the smallest possible value, we'll put the smallest numbers in the product and then add the smaller remaining number to it. So the smallest numbers are 2 and 3. 2 into 3 plus, now we'll add the smaller remaining number, which is 4. So n is equal to 6 plus 4, which is equal to 10. Now m minus n is equal to 23 minus 10, which is equal to 13. And this is our answer. So the correct answer is option C.
Suppose x, y, and z are variables taking positive real numbers as their possible values. It is given that y is directly proportional to x square and x is inversely proportional to z. For z equal to 7 by 25, the values of x and y are 5 and 50 respectively. If y equals to 98, what is z equal to? Now it is given that x, y, and z belong to positive real numbers. Also, it is given that y is directly proportional to x square, which means y is equal to k1 x square, where k1 is any constant. So this is equation 1. It is also given that x is inversely proportional to z, which means x is equal to k2 by z, where k2 is any constant. So this is equation 2. Now let's put the value of x from equation 2 in equation 1. So y is equal to k1 into k2 by z whole square. This is equation 3. It is also given that when z is equal to 7 by 25, x is equal to 5. So let's put those values in equation 2. 5 is equal to k2 by 7 by 25. Simplifying this, we get k2 is equal to 5 into 7 by 25. This, when simplified, gives us k2 is equal to 7 by 5. It is also given that when x is 5, y is 50. So let's put those values in equation 2. 50 is equal to k1 into 5 square. This gives us k1 is equal to 50 by 25. So k1 is equal to 2. Now let's put those values in equation 3 and let's put y as 98 and then find the value of z. So 98 is equal to 2 into 7 by 5 upon z whole square. So this gives us z square is equal to 2 into 49 by 25 upon 98. This, when simplified, gives us z square is equal to 1 by 25. So z is equal to 1 by 5. Since x, y, and z are positive real numbers, we are not taking the value of z as minus 1 by 5. So 1 by 5 is the answer and the correct option is option B. In an objective type question paper, 5 marks are awarded for a correct answer and 2 marks are deducted for a wrong answer. A student attempted all the questions and got a score of 69. Had he been awarded 4 marks for a correct answer and 1 mark deducted for a wrong answer, he would have scored 84. How many questions were there in the question paper? So let's suppose the number of correct answers is C and the number of wrong answers is W. C plus W is equal to the total number of questions, so N is the total number of questions. It is also given that when 5 marks are awarded for a correct answer and 2 marks are deducted for a wrong answer, the score is 69. So the equation becomes 5C minus 2W is equal to 69. This is equation 1. It is given that when 4 marks are awarded for a correct answer and 1 mark is deducted for a wrong answer, the score is 84. So the equation becomes 4C minus W is equal to 84. So this is equation number 2. From equation 2, we get W is equal to 4C minus 84. We'll substitute this value in equation 1. So we get 5C minus 2 into 4C minus 84 is equal to 69. So 5C minus 8C plus 168 is equal to 69. 3C is equal to 168 minus 69, which is equal to 99. So C is equal to 33. Now we'll substitute this value in equation 2. So 4 into 33 minus W is equal to 84. 132 minus W is equal to 84. W is equal to 132 minus 84, which is equal to 48. So the total number of questions is equal to the number of correct answers plus number of wrong answers. So N is equal to C plus W, which is equal to 33 plus 48, which is equal to 81. So the correct answer is 81 and the correct option is option B. What is the minimum number of times one needs to measure to get 298 liters of water from a tank if the measuring cylinders have the capacities 1 liter, 6 liters, 25 liters and 100 liters? So we need to measure 298 using 1, 6, 25 and 100 liter cylinders. Our first instinct would be to break down 298 as 100 into 2 times plus 25 into 3 times plus 6 into 3 times plus 1 into 5 times. So this gives us 2 plus 3 plus 3 plus 5, which is 13 measurements. But we are asked to find out the minimum number of measurements, so 13 may not be the right answer. So let's think of the nearest 100 to 298, and that is 300. So we'll break down 298 as 300 minus 2, which is 100 into 3 times minus 1 into 2 times. So this gives us 3 plus 2, which is 5 measurements. So the correct answer is option B. A pattern formed by two characters A and B is repeated more than once in the following string. So this is the string. What is cross cross in the 7th and 8th positions from the left in the above string? So the given string is cross B, cross A, cross A, cross cross A, cross A, cross B, A, B. Now we are asked to find what fills the 7th and 8th position. So let's count the number of characters in this string. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So for the pattern formed by A and B to repeat evenly, its length has to divide 15, which means that the pattern length has to be a factor of 15. So the pattern length can be 1, 3, 5 or 15. Now length 1 wouldn't work because that would mean that every character is same, but we clearly have both A and B. Also 15 won't work either because that means that nothing repeats at all and the question wouldn't make any sense. So we'll eliminate 1 and 15. Let's try 3 first as the pattern length. So that would give us 5 groups each having 3 characters. So let's divide the string into 5 groups. Cross B cross, A cross A, cross cross A, cross A cross, B A B. Now every column must have the same letter across all groups because that's what makes it a repeating pattern. So let's check column 1 across all groups. So C1 has cross A, cross, cross B. We have got both A and B in the same column. So this breaks the rule and 3 cannot be the pattern length. So let's try 5 instead as the pattern length. That gives us 3 groups of 5 characters. So the string becomes cross B cross A cross, A cross cross A cross, A cross B A B. So let's match column across each group. So C1 is cross A A. So C1 represents letter A. C2 is B cross cross, which means C2 is letter B. C3 is cross cross B, which means C3 represents letter B. C4 is A A A. So clearly C4 is A. C5 is cross cross B, which means C5 represents letter B. So the pattern is now A B B A B. This repeats itself 3 times. So the string becomes A B B A B, A B B A B, A B B A B. Now we have to find the 7th and 8th letter from the left. So 1, 2, 3, 4, 5, 6, 7, 8. So the 7th and 8th letters are B and B. So the correct answer is option D. A person facing east travels 4 km straight and then turns right and travels 3 km. Then further turns left and travels 2 km and finally turns left and travels 3 km. The minimum distance between the final point and the initial point and the direction in which the person is facing at the final point are respectively. So let's start by marking the directions. East, west, north, south. So the person starts by moving towards the east. So he moves 4 kilometers towards the east. Now he turns right. So right from east is towards the south and walks 3 kilometers. So he walks 3 kilometers towards the south. Now he turns left and walks 2 kilometers. So left from south is towards east. So he walks 2 kilometers towards east. Now he finally turns towards his left and walks 3 kilometers. So left from east is towards the north. So he walks 3 kilometers towards the north. Now you can observe that the vertical movement becomes 0 because 3 kilometers south is balanced by 3 kilometers north. So only the horizontal movement remains. So the final distance covered by the person is 4 kilometers plus 2 kilometers. So that is 6 kilometers. And the final direction is towards the north. So the correct answer is option D. In a sequence of numbers, each number other than the first two is the sum of the two immediately preceding numbers from it. If the first two numbers in the sequence are 4 and 7, then the sixth number is. So this question is quite easy. Let's solve it quickly. So it's given that every number after the first two is the sum of the two immediately preceding numbers, which means that every new number after the first two is obtained by adding the two numbers just before it. So the first two numbers are 4 and 7. The third number will be the sum of first and second numbers. So 4 plus 7 is 11. Now the fourth number will be 7 plus 11, which is 18. The fifth number will be sum of 11 plus 18, which is 29. And finally, the sixth term will be the sum of fourth and fifth numbers. So 18 plus 29 is 47. So the correct answer is option D. If the product of the HCF and LCM of two distinct numbers is the cube of one of the numbers, then which of the following statements are correct? So before reading the statements, let's understand the concept first. So the concept is HCF into LCM is equal to product of the numbers, which means that if there are two numbers A and B, then HCF into LCM of A and B is equal to AB. So let's read the question. The product of the HCF and LCM of two distinct numbers is the cube of one of the numbers, which means that AB is equal to A cube. This, when simplified, gives us B is equal to A square. So if one of the numbers is A, the other number is A square. Now let's read the statements. The difference of the numbers is an even number. So if A is an even number, A square will also be an even number. So the difference between any two even numbers is even. Now if A is odd, A square will also be odd. So the difference between any two odd numbers is also even. So statement 1 is correct. Now let's read the second statement. One of the numbers is a perfect square. So we clearly have A square as one of the numbers. So statement 2 is also correct. So the correct answer is option C. In a recruitment process, the selection of candidates is based on their performance in three components. The weightages of components 1, 2 and 3 are 0.2, 0.3 and 0.5 respectively. Use the data given below and find the cutoff score if exactly 3 candidates are to be selected. So this is a very easy question. We just need to calculate the weighted score of each candidate. So the weight of component 1 is 0.2, the weight of component 2 is 0.3 and the weight of component 3 is 0.5. And the weighted score becomes component 1 into 0.2 plus component 2 into 0.3 plus component 3 into 0.5. Now let's calculate the score of each candidate. So candidate 1 has a score of 5 into 0.2 plus 4 into 0.3 plus 6 into 0.5. So that is equal to 1 plus 1.2 plus 3. So that is equal to 5.2. Now let's calculate the score of candidate 2. So that is equal to 4 into 0.2 plus 6 into 0.3 plus 5 into 0.5. So that is equal to 0.8 plus 1.8 plus 2.5. So this is equal to 5.1. Now let's calculate the score of candidate 3. 3 into 0.2 plus 2 into 0.3 plus 8 into 0.5. So that is equal to 0.6 plus 0.6 plus 4. So this is equal to 5.2. Now let's calculate the score of candidate 4. So 9 into 0.2 plus 4 into 0.3 plus 3 into 0.5. So that is equal to 1.8 plus 1.2 plus 1.5. So this is equal to 4.5. Now let's calculate the score of candidate 5. So that is equal to 8 into 0.2 plus 8 into 0.3 plus 2 into 0.5. So this is equal to 1.6 plus 2.4 plus 1. So this is equal to 5. Now since exactly 3 candidates are to be selected, the cutoff is the third highest score. So the first 2 students get a score of 5.2 and 5.2. So the third highest becomes 5.1 and the correct answer is option A. There are two chemicals which do not react with each other. A container contains 10 liters of the chemical A. 1 liter of this chemical is removed from it and 1 liter of the chemical B is poured. Then 1 liter of the mixture is removed from the container and 1 liter of B is poured. If this process of replacing 1 liter of the mixture by 1 liter of B is performed once more, then what is the volume of B that is present in the container approximately in percentage? So before solving the question, let's understand the simple concept first. Whenever a fixed quantity is removed and replaced repeatedly, remember this formula. Amount left is equal to initial amount into 1 minus removed amount upon total amount to the power n. N is the number of times the operation is performed. So here the amount of A left is equal to initial amount is 10 into 1 minus removed amount is 1 liter and the total amount is 10 liters to the power 3 because the operation is performed 3 times. So this is equal to 10 into 9 by 10 to the power 3. So 10 into 9 to the power 3 is 729 and 10 to the power 3 is 1000. So this is equal to 7.29. Amount of A left is 7.29 and therefore amount of B is equal to 10 minus 7.29, which is equal to 2.71. So 2.71 is approximately 27% of 10 liters. Hence the correct answer is option B. 3 partners A, B and C entered into a business. A invested 1/3 of the capital for 1/3 duration. B invested 1/4 of the capital for 1/4 duration. C invested the remaining capital for the whole duration. Out of a profit of 17,000, how much profit will C get? So before solving, let's first understand the concept. In a partnership, profit is proportional to capital into time. So A's share will become 1/3 capital into 1/3 time. So let it be 1/9 units. B's share will become 1/4 capital into 1/4 time. So it will be 1/16 units. C's share will become 1 minus 1/3 minus 1/4 capital into time, since he has invested the remaining capital for the entire duration. So it will become 5/12 units. So the ratio of their profits will be 1/9 is to 1/16 is to 5/12. Taking the LCM of the denominators, we get 16/144 is to 9/144 is to 60/144. So the ratio of their profits will be 16 is to 9 is to 60. So C share will be 60 upon 16 plus 9 plus 60 into 17,000. So it will be equal to 60 upon 85 into 17,000. Simplifying this, we get the profit as 12,000. So the correct answer is option A. A shopkeeper employs a delivery boy and gives him a motorcycle for home delivery. For every delivery, the boy is given rupees 5. At the end of the day, he also gets rupees 2 for every kilometer of the distance covered in the day. The boy wants to earn more than rupees 500 a day but does not want to travel more than 100 km. Which of the following numbers of deliveries would definitely meet his target? So the earnings of the boy will be 5n plus 2d, where n is the number of deliveries and d is the distance covered. Also, 5n plus 2d should be greater than 500 for him to achieve his target, and the distance covered should be less than 100. So let's assume the worst case scenario in which the distance covered is 0. So 5n plus 0 should be greater than 500. This means that 5n should be greater than 500 and n should be greater than 100. So to absolutely guarantee earning more than rupees 500, he should make more than 100 deliveries. But none of the specific options A, B or C satisfy this condition. Also, the relation between the distance covered and the deliveries is not given. So the question cannot be answered due to insufficient data. Hence the correct option is option D. How many times does 5 appear in all 2-digit positive integers? So note that we are counting the occurrence of the digit 5 and not how many numbers that contain it. So every 2-digit number has a tens place and a units place. So we'll count 5s in each place and then we'll add. So first in the tens place, 5 occurs in 50 to 59. So this gives us 10 occurrences in the tens place. Now we'll count the units place. In the units place, 5 appears in 15, 25, 35 and so on till 95. So this gives us 9 occurrences. So the total number of occurrences are 10 plus 9, which is 19. Hence the correct answer is option B. Note that 55 is counted once while counting the tens place and once while counting the units place. So the double counting is avoided.
How many words can one form by shuffling the letters of the word Q if Q is always followed by U? The words thus formed need not necessarily have any meaning. So we have 5 letters Q, U, E, U, E. But since Q is always followed by U, we can consider this as a single block. Now we have to arrange 4 letters. So the number of ways to arrange 4 letters is 4 factorial. But since E is appearing twice, we'll divide it by 2 factorial. So our answer is 4 into 3 into 2 into 1 divided by 2 into 1. That is 12. So our answer is D.